Good morning, everyone. Welcome to Cells, and I just want to share with you how negative and positive regulations work. So first, I just want to let you try to understand what is native regulations mean. So native regulations, so the genes DNA acts is like a road, and then the road motors is like a gate that you're gonna have you to go into the genes to create the mRNA for that genes. So the repressors acting like a guy stand in front of the gate and try to stop the transcriptions. It depends on the ligate. With the presence of the ligate or without the presence of the ligate, this repressors guide gonna activate or not activate. So with the presence of ligate or without the presence of the ligate, as you can see. So the native regulations, you can think it as like a no. Native means like minus, right? Subtracts, mean there's no transcriptions happening. It depends on the presence of the ligate or not. The positive regulations, again, the DNA acting as a road, and then the promoter is a door and the doorway to get into the genes. So positive is mean adding, it mean yes, there's transcriptions happening, depends on the ligate. And in this case, the guy stand in front of the doorway is not it will be the activators. So Mr. Activators will acting as a helping to pushing mRNA polymerase, because mRNA polymerase is really slowly in doing the transcriptions, so that's why activators gonna help Mr. Activators gonna help mRNA polymerase to pushing her to make the transcriptions faster. It depends on the ligate again. With or without the ligate, there is a transcriptions activators or not. Now we're talking about the tryptophan operon of E. coli. First, before I talk about operon, I just want to mention that that the cells are very, very lazy. Unless you don't have any tryptophans in your body, cell gonna start to stand up and then starting to do the transcriptions to making a tryptophan. So tryptophan is like an amino acid that used to it's like a protein that help all the activities in your body that's happy to survive. Every time you breathe, every time you eat anything or you do anything, those activities is be made be work because of the protein that's do the job. The RNA and the DNA is more like a coding number that it's a coding, it doesn't do anything unless it's making the protein. The protein is the one that doing the job. So without the presence of the tryptophans in your body, as you see here, so with the high tryptophans in your body, as you see here, the genes will be turned off because you have enough tryptophan in your body. You don't need to make any tryptophans more. So that is when Mr. Repressors gonna stand in front of the doorway and with the presence of tryptophan is a ligand acting as the ligand gonna link with Mr. Repressors That's when Mr. Repressor stand in front of the doorway and block Miss RNA polymerase coming to and starting making the tryptophan. So Miss RNA polymerase gonna slowly coming to the doorway, and they say, oh, I wanna making some tryptophan. And then Mr. Repressor said, no, we have enough tryptophan in our body. I don't think we need more. So that's when Miss RNA polymerase have to leave. So there's no transcriptions be made. And when there is there's no presence or maybe low tryptophans in your body, that is when tryptophan ligand is not present. Mr. Repressors cannot stand in front of the doorway anymore, so Miss RNA polymerase can starting to make tryptophan genes, tryptophan mRNA will be made. She will start from the doorway, it's a promoters, and then starting to slide down into the end of the genes. Talking about the lactose operant in E. coli, lactose, when you drink milk, in milk have lactose, and lactose is a complex sugars. It's a diet sugar, so you need to have a protein. It's called lactose cheese proteins. The genes that sequence here is lactose protein that cut the bond between two simple sugars to make the lactose become simple sugars for the cell to digest. Again, cells are very, 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 very lazy. If you have simple sugars, it means glucose in your body. The cells will use up all of the simple sugar. It means glucose in your body. Even there is a presence of lactose, if we use the glucose, because it don't have to spend the energy to making a protein to break down the lactose into glucose, so it's use up all of the glucose. Unless you use up all of the simple sugar like glucose, the cell is gonna start to stand up and then making the protein to break down the lactose. So the lactose operant have negative regulations and also positive regulations. So first we talk about the negative regulations. The negative regulation we work with Mr. Repressors is the one who stand in front of the genes, the doorway of the lactose genes. So in our body have lactose, so the lactose gonna link with Mr. Repressors, and that if our body have lactose linked with the repressors, Mr. Repressors, that make Mr. Repressors gonna leave and will not stand in front of the doorway anymore because of the presence of the lactose. So that's open up our doorway, and Miss RNA polymerase can starting to slowly coming to the promoters. It means the doorway of the lactose genes. She's gonna come in and then starting to generate the mRNA lactose. However, Miss RNA polymerase is, like she's girly, she's very slowly, she just like enjoy life so much, so she moves slowly through the genes, lactose genes. That's when we need to have Mr. pushers, Mr. Activator. So lactose, the positive regulation lactose come in to speed up our lactose transcriptions. The important part in here is we need to have the C, A, and B is the ligand in our positive regulation lactose. If you have glucose in your bodies, that will inhibit the generations of C, A, and B from ATP. So if you want to have positive regulations happen, you have to make sure there's no glucose in the body. That's when the C, A, and B can be made, and the C, A, and B key ligands gonna bind into Mr. Activator, CAB, and he will do the job. It's like pushing and helping Miss RNA polymerase gonna move faster and speed up the transcriptions that making lactose genes, lactose mRNA, and speed up the transcriptions. That's how the lactose Operon's positive and negative regulations and also tryptophans work. I hope it's helped, and you guys are welcome to email me if you have any more questions, and then you can just ask me in the cells. And enjoy and have a good day.